Yes, good day class. Once again, we will be discussing scientific notation. So scientific notation in a nutshell is just representation of large or real small numbers. So how we do that is from the chart we spoke about earlier, the multiples and the submultiples of 10. How do you represent these large or really small numbers? Scientific notation is the way. 1.3 in your textbook. I'll post this in the class. So the basic concept is to get the decimal point to the right side of the first non-zero digit, and then you represent your movements by powers of 10. So you know this is less than 1, so if we need to get the decimal to the right side of the first non-zero digit, we just have to move one space. So it's 1, and move the one space times 10, but the space we moved it was from left to right, so it's -1. Because it was a smaller number, smaller than 1. In this case, 10,000, we need to get the decimal place to the right side of the first non-zero digit, which is this 1. So we have to move the decimal place 1, 2, 3, 4. So it's 1 times 10, and we move the 4 spaces. In this case, 0.001, we have to move the decimal place 1, 2, 3. So it's 1 times 10 to the -3. Now there may be a case where you have a number. Let's do this number 25. Now you notice there are 3 non-zero digits, but the key is to get the decimal to the right side of the first non-zero digit, which is this. So you know it's a positive number, so you know the decimal starts on this side. So to move it is 1, 2, 3. So now the decimal goes there. So it's 2.58 times the amount of times you moved it. 10 is to the power of 3. Let's get a small number. Okay. Really small number. 0.00075. Now to represent this, using the rule, you want to get the decimal to the right side of the first non-zero digit. Now there are 2 non-zero digits. The first one is the 7. So to get the decimal place to the right side of the 7, you have to move in 1, 2, 3. This is where the decimal ends up. So 7.5 times the amount of times you moved it. So it's 1, 2, 3, 4, 10 to the -4, because it was a number that started off smaller than 1. So we move from left to right, you know it's negative. If we move from the decimal from right to left, you know it's going to be positive. So it's always in multiples of 10. So the key is getting the decimal to the right side of the first non-zero digit. So we can get more in depth, but that's basically what you're doing. So it's just as simple as that. It's just a way of representing large numbers to make it more manageable to do your calculations. Good.